Hello, good morning, students. Welcome to the e-lecture series by LG Institute of Pharmacy. I am Dr. Jignesh Shah, working as a professor in the Department of Quality Assurance at LG Institute of Pharmacy. In today's class, we will continue with the topic that is UV visible spectroscopy. Now, in the last class, we have completed Bees and Lambert's law, that were the laws which were governing the absorption of the radiation by a particular sample. Also, we have covered the chromophore and the oxochrome concept, which were responsible for the absorption of the radiation. And in today's class, we will continue with the another topic, that is the formation of absorption bands, types of absorption bands along with their examples, and also we'll try to cover with the instrumentation of UV visible spectroscopy. Now, as all of us know that each and every molecule, it is composed of different functional groups as well as different bonds are associated with a particular molecule. Now, due to this reason, whenever energy is imparted to such kind of molecule, then the electrons which are present in the bonds of that particular molecule will undergo excitation from lower energy level to higher energy level. And because of this reason, it will give us a spectra, and analysis of this spectra will help us to predict that what kind of bonds or what kind of functional groups are present in that particular molecule, and this helps in the elucidation of the structure of that particular compound. Now, in formation of absorption bands, we know that the spectrum, it consists of different peaks, and these peaks are because of different functional groups present in a particular molecule. Now, each peak is corresponding to the promotion of electron from one energy level to another energy level. So, whenever we impart energy to the molecule, its bonds will absorb the energy, and by the absorption of the energy, the electrons associated with that bond will move from one energy level, that is ground state, to a higher energy level, that is the another electronic level. Now, during the promotion of the electrons from ground state to a higher energy level, this electron will move from one vibrational and rotational level which is associated with one mode. It will move towards the next electronic mode. So that's why there will be a transition which will be associated from lower level to higher level, because a quantum of energy has been absorbed by a particular molecule. Now, when molecule consists of large number of functional groups and bonds, there will be large possibilities that many of the bonds, they absorb similar kind of energy, and this results in large number of possible transitions from lower level to higher level. As a result, we will not be obtaining a single peak, but instead of that, we will be getting an absorption band. Hence, not just one but large number of wavelengths which are very close to each other, that will be absorbed by a particular molecule. So, similar kind of functional groups which are having similarities in their properties, they will be absorbing similar wavelength of radiations, and this results in an absorption band rather than getting us a single peak in an absorption spectra. That's why large number of wavelengths which are very close to each other, they will be absorbed by a molecule, and this results in the formation of bands. On analysis of the bands, we can identify that what kind of chromophore or what kind of functional group is associated with a particular molecule, and this helps us in distinguishing two different similar functional groups which are associated with absorption of similar energy which has been imparted. Now, this absorption bands, they are characteristic feature of different kind of compounds which are associated with different functional groups. That's why these absorption bands has been classified into four types, that is K band, R band, B band and E band. These are the four different absorption bands which are related to the absorption of energy, which are very close enough with a similar kind of functional groups or similar kind of compounds. First, we will be moving towards the first type of band, that is K band. Now, this is the most frequent band which has been found in majority of the spectrum, because K bands, they originate because of pi to pi star transition, and it is arising from a compound which is containing a conjugated system. That is, it is arising from a system which is containing double bonds or triple bonds. Now, as all of us know that most of the organic compounds, they are associated with conjugated systems, or they are associated with the pi bonds present in the molecule. And as a result, these K bands are most frequently observed in a particular spectra. Now these K bands, they are due to pi star transition. That is, the electrons which are involved in the pi orbital, or which are associated with the sharing of electrons in a pi bond, they will absorb the energy and they will move to the anti-bonding pi orbital, which is known as pi star orbital. And due to this transition, K bands will originate. So this transition will help us to give K bands. Now these type of K bands, they are mainly found in compounds such as dienes, or in case of polyenes. They are also found in case of compounds such as enones. Now here are a few examples which is pertaining to the K band. They are, in case of acetophenone, we can see that there is pi to pi star transition, and the lambda max in case of acetone, it is found near 240 nanometer, and the Emax value was found around 13,000. Whereas in case of 1,3-butadiene, which is a diene containing two double bonds, here also pi to pi star transition takes place, and the lambda max is found at 217 nanometer, which is suitably less, or we can say it is reasonably less as compared to the lambda max which is found in case of acetophenone, and the Emax value is more as compared to acetophenone. It is around 21,000. These K bands, they are also been seen in case of benzene, which has substituted chromophores, because benzene is also a compound in which double bonds are present, and they also undergo pi to pi star transition. So the most important thing which should be focused here is these K bands are arising due to pi star transition. So wherever there is a possibility of pi to pi star transition, we can see K bands which have been originated, and they are found in the spectra of such kind of compounds. The second type of band which is obtained, they are known as R bands, and they originate due to N to pi star transitions. These are the second frequent type of bands which are seen in case of a UV visible spectra, because most of the compounds, they are organic and they contain heteroatoms, and these heteroatoms, they have at least one lone pair of electrons, and due to this one lone pair of electron, the transition will take place from N to pi star level, because N electrons, that is non-bonding electrons, are present in such kind of molecule. So here R band transitions, they originate because of N to pi star transition, and here the single chromophoric group will be present, and they have at least one lone pair of electron which is present on an heteroatom, which makes possibility of N to pi star transition. That's why R bands will originate due to N to pi star transition. These are less intense with respect to Emax value, and the Emax value, they are always found below 100, because they are associated with lower energy, because N electrons can be easily excited to pi star transition level, or to the pi star anti-bonding orbital. Here are some examples with respect to R band. Here we can see that acetone undergoes N to pi star transition. We can see the lambda max of acetone, it is 270 nanometer with Emax value 15. And the second example is acetaldehyde, which also undergoes N to pi star transition with a lambda max 293 nanometer and Emax value 12. Both acetone and acetaldehyde, they are similar kind of compounds with a minor change in the functional group, resulting in same kind of transitions and almost similar Emax value. That's why R band will help us to identify or to distinguish between two similar kind of compounds with a change in lambda max value as well as with a change in the Emax value. The third type of band is known as B band. This B band, it arises due to pi to pi star transition in an aromatic or heteroaromatic molecule. So this is similar to K band, but here the transition, it takes place with respect to either an aromatic molecule or an heteroaromatic molecule. Now benzene, it shows absorption peak between 230 to 270 nanometer, which is an aromatic compound and which is most frequent ring structure, which is present in organic molecules. Now, when we attach a chromophoric group to the benzene ring, in that case, the B band are observed at a longer wavelength. Now, as we have gone with a different kind of shift, which are associated with UV visible spectroscopy, that is bathochromic shift, hypsochromic shift. This is one kind of example of a bathochromic shift, where when a chromophoric group is attached to the benzene ring, then the wavelength will be shifted towards the longer side. So in case of benzene, the pi to pi star transition takes place with a lambda max of 255 nanometer and Emax value is 215, whereas on substitution of a chromophoric group such as OH group in case of benzene, it results in the formation of phenol, and this phenol undergoes same kind of transition, pi to pi star transition, but the lambda max has been shifted towards the longer wavelength, that is towards 400 nanometer, resulting in the lambda max at 270 nanometer with a higher Emax value, that is 1450. So just by adding a chromophoric group to an aromatic molecule, there will be B band which will be formed, and this results in the increase in the lambda max value towards the 400 nanometer. So the B bands are observed at longer wavelengths than the more intense K bands. So K bands, they are been found at a shorter wavelength. Now moving towards the fourth type of band, which is known as E bands. These E bands, they originate because of the electronic transition in benzenoid systems of three ethylenic bonds which are in a closed cyclic conjugation with each other. Now, these kind of benzenoid systems, they are found in case of the structure of phenolphthalein, which is used as an indicator in acid-base interaction. These benzenoid systems, they contain a closed cyclic conjugated system. Now, due to this closed cyclic conjugated system, E bands, they are characterized into E1 and E2 bands. So, E band is further classified into two types, E1 and E2 bands, where E1 bands will appear at shorter wavelength and they are usually more intense as compared to E2 bands, and these E2 bands, they are appearing at a higher wavelength and they are less intense. Now, these kind of bands, they are seen in case of naphthalene and benzene, which are closed conjugated cyclic conjugated systems. So naphthalene also consists of a closed cyclic conjugated system. Benzene also consists of a closed cyclic conjugated system. Even anthracene is another example where we can see closed cyclic conjugated system. So naphthalene shows E1 bands at 221 nanometer and it shows E2 band at 286 nanometer. So here we can see that two different bands have been obtained because of naphthalene molecule, where the first band, it is obtained at 221 nanometer, which is towards a shorter wavelength, whereas E2 band is observed at a higher wavelength, that is 286 nanometer. So such kind of presence of two bands will give us an idea that the compound, it consists of a cyclic conjugated system or not. So these kind of examples such as benzene also shows E1 band at 184 nanometer and E2 band at 204 nanometer. As a result, we can easily distinguish such kind of compounds which have cyclic conjugated system with respect to those compounds which have open conjugated systems. So E bands are most commonly used to find out cyclic conjugation in a particular molecule. In the next class, students, we will move forward towards the instrumentation that is used in UV visible spectroscopy, where we will study about different types of instrumentation, different parts of instrumentation, along with their construction as well as working. I request all of you to follow the YouTube channel, that is Pharma Ignite, for the videos related to your academic session. Thank you very much.